Hi, Assalamualaikum warahmatullahi taala wabarakatuh. Welcome to our video presentation on Thermodynamics 2. First of all, I want to introduce my group. My group are the one. Yeah, this is our symbol logo, the one. Okay. This is the one group member. First, Mr. Zaru Anwar bin Zamri. Second, Muhammad Zaid bin Asman. Mr. Maliana binti Sa'id. And myself, Muhammad Haswanizah bin Ma'asyim. Right. This is our task, our assignment group, that is Steam Plant Learning System, SPLS. Okay. The purpose of the Steam Plant Learning System are identify equipment in steam plant, analyze the steam plant system, the third, troubleshoot the steam plant system, and finally, make the procedure of the operation easier. Alright, this is the DIY concept of SPLS, or Steam Plant Learning System. As you can see how the steam operates turbine to generate electricity, so the fan can move. Alright. Now, this is the overview of our component and circuit of our plant. Okay, I will go step by step to explain how our plant works. Okay, first, the source of water from the cooling water for condenser. The water is moved to the water softener. Okay, the water softener is a filtration system that moves hardness causing calcium and magnesium mineral. A water softener addresses one of the most prevalent and devastating water problem, that is hard water. Next, after the water treatment in the water softener, the water will be enter to storage tank. In this plant, there is two storage tank. First of all, fresh water tank. From the water softener, the water will be stored in this storage tank. The storage tank is for boiler operation. The second tank are diesel oil tank. The purpose of diesel oil tank is to store diesel oil for boiler combustion. Alright. After the water stored in the fresh water tank, the water will be transferred to the boiler. Okay. Alright. This is the boiler. Okay. The boiler will running the process for producing the saturated process. Alright. Next step will be explained by my colleague, Miss Melanie. So I will pass over to her. Thank you.
Thank you, Mr. Haswarizal. Hello, hi, I am Mariani Design. Just now, Mr. Haswarizal generally give us the flow of steam primary system. So now I will continue to explain about superheater, turbine, alternator, and condenser in the system. As we know, a superheater is a device to convert saturated steam or wet steam into superheated steam or dry steam, which is used in a steam turbine for electricity generation, steam engines, and in processes such as steam reforming. In this boiler system, a superheater function is to heat up the saturated steam to superheated steam as pictured shown. Turbine is a device that harness kinetic energy from any form of fluid like water, air, steam, or other gases and converts it into rotational motion within the device. So, turbine in the system function is to convert the potential energy into mechanical energy. It drives the ship's propeller or alternator to produce high quality water, which is no unused particle, mineral, and chlorine. We know alternator is a type of electric generator used in modern automobile to charge the battery and to power the electrical system when engine is running. So, in this learning project system, an alternator is driven by steam turbine. It converts the mechanical energy to power the electric energy when it is running. A condenser in the system also is to receive the steam which come out from steam turbine. So the steam will be converted to the condensed water to condensate water tank. So fresh water will store the condensate to use in the system again and again. So that's all for me. Now I want to call Mr. Muhammad Zaim to continue this presentation by his topic about thermal efficiency calculation. Thank you.
Okay, thank you for my friend Muhammad Leni. My name is Muhammad Zaim bin Osman. I would explain about thermal efficiency for steam plant learning system using Rankine cycle. So this is a simplified flow diagram, and this is a TS diagram for the system. Based on TS diagram, it has 4 states. I would explain how to calculate the thermal efficiency. For state 1, the value of pressure 1 is 75 kilopascal and the phase is saturated liquid. From the table saturated water, the value of enthalpy for state 1 is 384.39 kilojoule per kilogram, and the value of specific volume at state 1 is 0.001037 meter cube per kilogram. For the state 2, the process is process 1 to process 2. It's called isentropic process. The pressure at state 2 is 1.5 megapascal and the phase is compressed liquid. And we know entropy for state 2 equal to entropy to state 1. To get a value of enthalpy for state 2, we use the formula work pumped in equal to specific volume multiple pressure 2 minus pressure 1 equal to enthalpy for state 2 minus enthalpy to state 1. And the value is for enthalpy state 2 is 385.868 kilojoule per kilogram. For the state 3, the pressure is 1.5 megapascal and the temperature of state 3 is 280 degrees Celsius. From the table saturated water, we get a phase is superheated vapor, and the value of enthalpy is 2957.88 kilojoule per kilogram, and entropy for state 3 is 6.8353 kilojoule kilogram Kelvin. For state 4, the process is process 3 for process 4 is called isentropic process. The pressure for state 4 is 75 kilopascal and the phase is a saturated mixture. Entropy of state 4 is equal to entropy for state 3. To get a x4 value is we use formula is x4 minus sf alias 75 kilopascal divided by sfg at 75 kilopascal, and to get enthalpy for state 4 we use H half at 75 kilopascal plus x4 multiple HFG at 75 kilopascal, and the enthalpy for H4 or state 4, the value is 2604.83 kilojoule per kilogram. To calculate the Q in, we use formula Q in equal to H3 minus H2, and the value is 2436.312 kilojoule per kilogram, and Q out is H4 minus H1, and the value is 2405.142 kilojoule per kilogram. To get the thermal efficiency, we use formula. The thermal efficiency equal to works net divided by Q in equal to 1 minus Q out divide Q in. The value of thermal efficiency for the system is 0.8423 or 84.23%.
Thank you, Mr. Zaim. Now, it's my turn to proceed. The improvement SPLS system, we design steam header. Steam exit the boiler through piping, referred to as the steam header. The header also serves as a reservoir that feeds steam to the individual heating circuit. The steam header must be large enough to virtually eliminate pressure drop between the boiler and the beginning of the circuit. Steam header also to ensure constant pressure and temperature. The engineering analysis. We use the Autodesk Inventor Professional 2021 software to get the analysis. The von Miser stress, the maximum value is 0.6654 and the minimum value is 0.0007. For the displacement, the maximum value is 9.267 exponent minus 5, and the minimum is 0. The safety factor. The maximum value is 15, and the minimum is 0. For the technology readiness level, our product is level 9, complete operational, evaluation, and ready for full rate. System proven through successful mission operation. The testing and commissioning, as well as by Mr. Shahrizam bin Shahruddin, Marine Lecturer from UniKL MIMET. The suggestion and conclusion. First, to ensure safe and high efficiency. Second, to ensure student comprehension need industrial requirement. And the last, international accreditation. We got the International Award of Merit, the Malaysia-Croatia Technology Exchange 2021. In category Public Service Innovation Award 2021. The right side is our design using the Autodesk Plan 3D. This is a STEAM Plan learning system implemented by UniKL MIMET. That's all. Thank you.